What I'm going to do is maybe do a little bit of history lesson so that we can look at all the things that have been tried and tested and, and not necessarily successful in the California compliance process. So I'll run us back to 1978 when the Energy Commission introduced the standards, and we had some fairly simplified approaches to compliance. Prescriptive packages were package A, the classic package for residential, was introduced in 78. The industry immediately needed flexibility in terms of compliance. So in moving towards giving the industry that flexibility, the California Energy Commission developed some simplified compliance methods, which were very popular. As an example, we had the point system for residential, a series of plus and minus points depending upon building energy efficiency measures. And while on the surface that sounds simple, you had some fairly complex tables, multi-lookups, et cetera, different tables for different climate zones. So that actually led into software implementations for the point system. And on the non-residential side, we had some simplified calculations which attempted to look at the building performance in an equation-based, simple equations that you could do with a calculator, et cetera. Although ultimately those equations turned out to be a little bit more complicated than the average person could do in the calculator. So that also led into software tools that were able to do those equations and document compliance. Moving further ahead, we had an introduction of something called the SCM Simplified Calculation method. That was in the late 80s. Tagi Alareza with ADM Associates, I believe he had some DO2 involvement early in his career, introduced that. That became a fairly popular compliance approach for non-residential buildings because it allowed a lot more flexibility than the simple equation-based calculations. Ultimately, we had a lot of abuse of calculations in the 80s. People would basically do calculations where they'd use performance modeling tools. So we introduced DO2 as a calculation, train trace, carrier HAP. There are lots of different calculations you can use. They're all acceptable. But the key being that you had to calculate your own budget. And that didn't fly. Now, they tried introducing fixed budgets, and fixed budgets, we had situations where people were basically getting some ridiculous things to comply, and reasonable designs weren't complying. The fixed budget was determined not to be effective. So in 1992, we introduced the quote custom budget. That's what it was called back then. And the idea being that the software would automatically determine the budget. Now, that eliminated the abuse that was going on in the industry where people were randomly coming up with their own energy budgets. And that also had the effect of eliminating most software tools out of the industry, because the carriers of the world, the HAPs of the world said, well, look, we're selling software in other states. We're not going to come along and focus on just California here and jump through all these hoops. So it had the effect of basically eliminating a significant portion of those calculation tools, but rightfully so, because people were using those tools to abuse the system. So over the years, that was the 1992 Acm Manual, which sort of kicked things off in terms of this whole thing. That evolved over the next 25 years. The Energy Commission in 2013 revamped that Acm Manual. And what they did there is they took a page out of ASHRAE and they put in semi-fixed budgets. If your building is above a certain size, if your building is this and that, then your budget is going to be set accordingly, instead of following what was followed before, which was the prescriptive criteria. So suddenly we had HVAC systems that were no longer complying with the performance approach, yet they complied prescriptively. And Mike Gable was a big screamer on this particular issue, made a lot of noise in 2013 about the fact that they were no longer following prescriptive with the Acm Manual. So, and I did see some comments recently from NRDC to that effect on the 2022, refreshingly so, the 2022 ACM manual. So anyway, we tried out all these different things. Some things were successful, some things were not. But ultimately, your question is where are the complexities lying on this stuff? So the complexities generally are derived right back to the energy code. I know you didn't want to hear that, and I'm sure that a lot of people on this call don't want to hear that. But ultimately, these complexities, people complaining from the user side, are derived from complexities in the energy code. So the question is, are these things we should be modeling? For instance, we have parking garages in our current range of tools. What do parking garages have to do with the performance approach? Why are we modeling parking garages, et cetera, et cetera? In the residential tools, we have the residential garages in the modeling tools. Why are we modeling those? There's no energy efficiency involved in a parking in a residential garage, et cetera. So there's all this other stuff that's getting fed into the performance approach, and the performance approach is really not intended to be a measurement of the accuracy of the performance of the building. It never was. It's intended to be, does this building meet code? And you've got a prescriptive code that tells me if this building meets code. And the performance approach over the years has tried to be used as an energy performance metric. There's been a lot of organizations that have pushed this stuff in there. And as we push stuff in there, we have to remember that it has to be validated and verified by the enforcement agency. That's a
Giving you
lesson I
a
learned back.
quick 2-minute flag, Martyn.
Yep, no problem, no problem. That's a lesson we learned back in the 90s. Is you can't just start putting stuff in there and saying, hey, here's an energy management control system, and now you're going to get energy efficiency credit for the energy management control system. Well, efficiency credit, how was that system programmed? Was it programmed correctly? Who set it up? How does the inspector validate that? So there's all these things that came along. There were things tossed around with ideas about having third party do validation of these energy efficiency measures. And that's something we discussed back in 2013. I thought it wasn't a bad idea to say, okay, if you're going to put in these basic measures, then you can go ahead and model those. However, if you want to push into these other energy efficiency measures or modeling twists, et cetera, then it requires third-party verification of your energy model. So that was toyed around with, and it almost flew in 2013, but it got pulled out at the last minute. So anyway, there's a little history lesson on things we've tried, things that have worked, things that have not worked. And of course, I mean, one of the discussions is, of course, the complexity for the user, but another discussion is the complexity for the vendor. So, and I know that one's kicking around these days a lot. So, okay.
Thanks, Martyn.
Mm-hmm.
And then have you heard anything from students? I heard that in your advanced energy modeling course, sometimes you ask students, what are your perceived difficulties?
Sure. The difficulties they're running into are typically difficulties with interpretations of the energy code when it comes to the software tools. Let's take a simple residential example. How is this ADU treated? Is it new construction? Is it an addition alteration? I know that sounds really simple to everybody on the line, but this is the sort of stuff that comes along here. And you know, I can morph that into your HVAC systems when it comes to non-residential applications, et cetera, et cetera. So as we introduce all these modeling capabilities, that's all fantastic, but that's more complexity that's being introduced into the software tools.